Calculus students, welcome to our final and hopefully shortest lesson of our unit on conic sections. So our goal for today is to simply to be able to look at an equation and determine which conic section it goes with. So the nice thing about this lesson is you're not required to really do any work. You don't have to do any completing the square. The goal is for you to look at the equation and based on the characteristics of the equation, determine which conic section it goes with. So here are some quick examples. So take a moment, pause the video, and just look at each equation and without doing any work, see if you can identify from what's in the equation which conic section each equation would be. Okay, so how can we go through, we'll check and see how you did. So how can we determine which conic section we're looking at just based on its equation? So as we said throughout this unit, each equation or each conic section has its own special characteristics in the equation. And so if you know which characteristics to look for, you can identify these fairly quickly. So let's look at equation A. Okay, notice that both the x's and the y's are squared. So it's not a parabola because we know a parabola only has one variable squared. So we can eliminate parabola. Now, all of the other conic sections, the x squareds and the y squareds are on the same side. So if we subtract 4y squared from both sides, we get an equation that looks like this. 0 equals x squared minus 4y squared minus 4x. Sorry, that should have been a y there. That y was sloppy. Well, now you can answer the question. If you look, because the x squared and the y squareds are being subtracted, it's a hyperbola. That is the only conic section that has a subtraction in it. So we can identify this first equation as a hyperbola. Let's go to our next equation. Once again, you notice the x and y's are both squared, so that eliminates a parabola. Notice we have a plus sign, so that eliminates the hyperbola. So we just have to determine, is this an ellipse or is it a circle? Well, without actually having to go through the process, if you look at these coefficients in front of the square terms, hopefully you remember that if we were to do completing the square, we would get different a squared and b squared values in our equation, which makes it an ellipse. So that's how we can determine that one. If we go down to equation C, right away, this should be pretty quick and easy. Notice that the y's are squared and the x's are not. That makes it a parabola. A parabola is the only conic section with one of the variables squared. All of the other ones, both the x's and the y's are squared. Going down to the final equation, once again, the x's and y's are both squared. That eliminates the parabola. There's a plus sign between the square terms that eliminates the hyperbola. So we're down to either a circle or an ellipse. Again, if we look at the coefficients in front of the terms that are being squared, they're the same. And if we were to do completing the square, we get an equation where the a squared and the b squared terms are identical, which means we're going the same direction in both the vertical and the horizontal. And that would make this the equation of a circle. Okay, so if you understand that reasoning and how we can use the clues in the equation to identify which conic section it is, you should be all set for your practice assignment. Good luck.